average value of a function. And if you think about average value, let's say you have a string of numbers like 3, 4, 8, 12, -6, 10. If you're going to find the average, what you do is you add them up and you divide by how many there are. So 3 plus 4 plus 8 plus 12 plus -6 plus 10, just to prove my point, divided by 6. There are 6 of them. That's not really important, so that's not what we're looking at. But if you look at a function, let's say you look at some function f of x. Now, f of x is a variable function, so when you want to find the average value, you're going to consider the interval from a to b. The average value is 1 over b minus a, the integral from a to b of f of x dx. So average value is not very hard to do. You just have to know your integrals and do it well. If you were to consider this geometrically, first of all, take a minute and write that down. This is the formula you need for average value of a function. But if you were to consider this geometrically, like the average value, there's a pretty proof for it, but you have a rectangle here. So if you were to multiply the b minus a to the other side, you'd have b minus a times the average value, which is whatever that height may be. And then this equals the integral from a to b f of x dx. If that doesn't make sense, it's not really a big deal, but here you have b minus a, which is the length of the rectangle, times the height of the rectangle, which is the f average, and it works out to be the area under the curve. So it's a really cool little idea there. So let's look at one of these. Let's just do a basic, let's let f of x equal x squared plus 1 over the interval. They say on or over, it depends on which textbook you're using, -2 to 2. So if you think about, you don't need a graph for these, but x squared plus 1 is a parabola that looks like this. It crosses the y-axis at 1, and our x values, the interval is -2 to +2. So we're going to, if you write the formula every time you use it, let's not keep that there. But if you write the formula every time you use it, it will help you learn it. So f average is 1 over b minus a times the integral from a to b f of x dx. There's two things about writing it. If you write it, it will help you learn it. And secondly, if you write it, you'll make sure that you didn't lose any parts of it. And I have seen some math book recently that instead of f average, they're doing f bar. And that's the notation in statistics. When we say the average of x, we say x bar or s bar. So I have seen that notation recently. If you see it, it's not too crazy. We're going to say 1 over b, which is 2, minus -2, which becomes +2. The integral from -2 to 2, and f of x in this case is x squared plus 1 with respect to x. Now, like I said, average value of a function is pretty cool because it's the integrals are not too difficult at this level of the book. Some books it comes after you sub, and so it gets a little more tricky. So we have 1/4 times the integral. Well, we can go ahead and integrate that. So let's take that integral symbol out and let's use parentheses. When we integrate x squared, we add 1 to the power to be x to the third. So we have 1/3 x to the third plus x. Let me back up and do that again because the reason I put this section here is to brush up on our integral skills. So if you know this, this will be nice and easy for you. When you integrate, you add 1 to the power and divide by the new power. So 1/3 x to the third plus. Now the 1 is really difficult for some people. There's no variable there, so we're going to put an x because when you have no variable, technically it's x to the 0. So when you add 1, it becomes x to the first from -2 to +2. So we have 1/4. We have 1/3 times 2 to the third is 8. So we have 8/3 plus 2 minus 1/4. And 2 to the -2 to the third is -8 over 3. And then we have -2. I'm going to pull these 1/4 out and distribute the negatives. We have 8/3 plus 2 plus 8/3 plus 2. Hopefully that's not some crazy magic there. So I factored the 1/4 to the front and then distributed the negative, changing both of those signs. So now we have 1/4. If we add these, we have 8/3 plus 8/3 is 16/3 plus 2 plus 2 is 4. So we have 1/4 common denominator, 3, 3. So we keep the 16, and 4 times 3 is 12. So we have 1/4 times 28/3, which becomes 7/3. So the average value of that function is 7/3, which is a little more than 2. So the average value of the function, if we were to look at it pictorially, is about here. Well, not quite that high, but it's a little more than 2. Let's bring it down a little bit. So that's the average value of the function. Because it's a function and we don't have discrete numbers, we don't have set numbers that we can add, the integral allows us to find the average value of the function. Let's look at another one. Let's say f of x equals x squared times x plus 5 over the interval or on the interval from 0 to 3. Oh, brackets. College algebra interval notation. All right, so average value of a function, this is the most common notation you'll see for average value of a function. So it's 1 over b minus a, the integral from a to b, f of x dx. So let's say f average equals 1 over b is 3 minus a is 0. Oh, pause the video and work through this because it's very similar to the last one, and then come back and follow along. You should always work through a math video with pencil and paper and pause and rewind if you get lost. So the integral from a, which is 0, to b, which is 3, and then f of x is x squared times x plus 5 dx. So 3 minus 0 is 3. Now here's the deal. You can't integrate x squared times x plus 5. You have to, and there is no product rule or quotient rule for integrals. So you need to distribute, call this x to the third plus 5x with respect to x. Now we can integrate that. X to the third, when we add a power, it becomes x to the fourth, so it's 1/4. Plus x squared, when we add the 1, we get a 2, so it's 5/2 from 0 to 3. Now this notation right here, this line means we're evaluating with the bounds from 0 to 3. It literally means f of 3, capital F of 3, minus capital F of 0, because the capital F means that we have integrated. So let's take that back out because it's not important to be written. So we have 1/3 times 3 to the fourth is 81 over 4, plus 3 squared is 9 times 5 is 45 over 2 minus 0 minus 0. So we have 1/3 times 81 over 4, plus we need a common denominator of 4, so this will be 90. So we have 1/3 times 171 over 4. That's not going to cancel, so we're going to have 171 over 12. That's what happens when I make up these beautiful problems. They're not always beautiful. Let's do another one. It says, let's let f of x equal 1 over x squared plus 4. And let's use the interval 0 to 1. We should be fine there. So again, our formula. Pause for a minute and come up with the formula. You should pause. So it's 1 over b minus a, the integral from a to b, f of x dx. So the average value of the function is 1 over 1 minus 0, the integral from 0 to 1, and we're integrating 1 over x squared plus 4 dx. So 1 minus 1 is 1. That's nice and pretty. Now when we integrate this integral, this is our inverse tangent integral. So that means that a equals the square root of 4, which is 2. That's an integral you should learn. Let's make a note real quick. Let's erase this and throw a note in here. Oh, well, I did something, so I can't erase. But let's make a note maybe at the bottom. Let's do that. Note. The integral of 1 over x squared plus a squared with respect to x is 1 over a inverse tangent x over a plus c. So you'll see how that comes in handy on this one. So we're going to say a is 2, so we have 1 over 2 inverse tangent x over 2 from 0 to 1. So we have 1/2 inverse tangent of 1/2 minus 1/2 inverse tangent of 0. Inverse tangent of 0 is 0, so that's not bad. Let's talk about the inverse tangent of 1/2. That's not one we know off the top of our heads, so we're just going to leave that as inverse tangent of 1/2 minus 0. So we have 1/2 inverse tangent of 1/2. You could go ahead and find the value if you'd like, but remember that we work in radians because we are in Calculus 2. So it's important that if you're going to find the value, go ahead and do it in radians, okay? One more. Let's look at the average height of a wave. So the wave is defined to be f of x equals 5 times 1 plus cosine of x. And so what we have is we have a wave that looks like this. If you think about your cosine graph, that's what it looks like. I didn't draw that well because it's going to hit the axis. If it moves up 5, right here, the center moves up 5, so it goes up to 10 and down to 0. And then we're going from negative pi to positive pi. So if we look at that wave, we can find the average value of that wave. It probably isn't very difficult. What they're talking about here is this is the low point of the wave, and then it reaches the maximum up here at 10. So the average value of the function then would be, we're going to go from negative pi to positive pi. So we have the formula 1 over b minus a, the integral from a to b, f of x dx. So 1 over, the b value here is pi minus negative pi, the integral from negative pi to pi, and our formula is 5 times 1 plus cosine x dx. So we have 1 over 2 pi. It's an interesting fraction. The integral from negative pi to positive pi. Now there's two things you can do with this 5. You could distribute the 5, or you could pull this 5 out front because it's multiplied times everything here. So let's go ahead and do that. Let's bring this 5 out to the front, and it's a whole number, so it will go on top. So we're going to say 1 times 5, and then we have 1 plus cosine of x dx. So now we have 5 over 2 pi, and when we integrate 1 with respect to x, we get x, and when we integrate cosine with respect to x, we get positive sine of x from negative pi to pi. So now we have 5 over 2 pi, and we're going to say, when we evaluate at pi, we're going to say pi plus sine of pi minus negative pi minus sine of negative pi. So we have 5 over 2 pi, we have pi, and then sine of pi is 0, and this becomes plus pi, and sine of negative pi is also 0. So we end up with 5 over 2 pi times pi plus pi is 2 pi. So the average value is 5. If you think about the wave, that makes sense. So I hope this makes sense and that you understand the questions that you need to do. And let me know if you have any questions. Have a great day.